Yeah, so can you, no, you cannot see this yet. Just let me, yeah. I hope you can see my screen. Yes. Yes.
Yes, sir.
Okay. So let's start. I mean, yeah, forget all this. We'll come back to this later. Well, so this is what we'll do. Find the, this is absolutely elementary. Find the max element in an integer array. So someone tell me what to do here. So first declare an integer array, and how do we do that? So the name of the array is AR. How should we do? How should we declare an integer array of 10 elements? Yes. The data type is what?
So we can just say int and the name of the array and square brackets. And then
10. Tell me 10 numbers. How many are there? 9. And say 4, 5, 6, 7, 8. Okay, 7 we have done. This seems to be okay. And in max. Then, so what should be the loop? I want to extract the maximum element. So max will be my this element, extra element, and what should it be? Tell me a while loop. So someone else, please tell me a while loop to extract the. So I prefer that the non-mathematics students try to answer, please. Any non-mathematics students present here right now? No one. Okay. So someone from maths, please tell me a while loop to extract the maximum element from here.
So first we can initialize max to int min instead of just keeping it uninitialized.
Sorry, max should be?
You can keep the initial value of max as int underscore min, the minimum integer.
Well, so I don't know what int underscore min means, so let's not do this. Tell me something else.
So we can take the first
We can
element
take the
of
first
array.
element.
First element.
Max is equal to, this is what you are saying. Okay, fine. Then,
So then we take a variable to iterate through the loop.
okay, int counter is equal to, we can put this is equal to 1, right? Because this
Yes,
max
sir.
is already taken. So then what should we do?
Then while the counter is less than 10, we can iterate.
While counter is less than 10, if array counter is greater than max, max is equal to array counter, and okay, and we get this right. This should give us the maximum element, yes. And so now just think about it. I mean, it's not much when you do it, but this is something that will help you in the lab. Yeah, don't say the answer. Take a few minutes to think, and don't give the answer till I ask you again. Can you do this without a loop, like without an explicit while, do while or for? Find the maximum element without the loop. So let's all think about this for 5 minutes or so. Yes. Okay. So before we learn how to do this, let's go back a bit. So we have learned about functions, and so int if sum is, say, it takes int a and it takes int b, and it will say sum. So like, let me say a is equal to a plus b. and it will see out A, and let this be a, yeah. So just let this be point. Okay. And yeah, so let's forget this part. We'll come back to it later on. Int A is equal to 7, B is equal to 5. Then I'll say f sum A comma B, and then I also see out A. And let's see what this gives. More functions. CPP. Oops. F sum was not by given underscore. So you can see that yeah, though we have in the function, though we have increased the value of A, so here, so this is what the function outputs. The value of A remains the same in the original, in the main body of the program. That means, so yeah, increased, so main function prints the original value of A instead of the value of A increased by f sum. So as some of you had said earlier, that the a copy of the A is passed to f sum, right? So this is called by value. Okay, so this is how it is passed. Let's try, I mean, but yeah, can we do the same with an array? That's what I'm thinking. Let's see what happens with an array. Void like that, and this is our second. So what was the notation to pass the an integer array to a function? Int. It was like this or the other way? It was this or anyone?
Yes, sir, it was this.
It was this, okay. So yeah, what we'll do is that 0 is equal to maybe 2, or maybe not less, and then we say int I equals to 0. So this is a 10, right? While I less than 10, cout I plus, and there you have this cout, and then so let's do this. We can do here with counter. Okay, so yeah, I'm not calling the function first. Just let's see. Okay, fine. This was the original array. Fine. Okay, and then we can call, what was the name of this guy? Printer. Okay, so print tag gives a 6 plus 4 equal to 10. Okay, fine. Oh, so why? See, this magic has happened just now. Unlike for a single variable, which was increased by the sum function, but the original value was retained in the main function. See, you can see when we increase the value of function, I mean value of an entry in an array, in the main function also it is increased. Why? Why is this happening?
So while passing the array, we are passing the address.
Sorry, I cannot hear you. Can you increase your volume, please? Please increase your volume, whoever answered, and repeat what you said. Yes, please, anyone, can you say why this is happening? Why is an array changed? Like, so it seems that the array is actually, so changes made in an array element by a function are retained in the original array, implying that the original array and not a copy are, so is passed to a function. So remember this. In the future, we'll we'll learn to write this in another way, which will make sense why this is like this. So yeah. So my question for the time being is, so this kind of magical thing, changing the original value through a function. So I have what, A, B, right? And now what I want you to do is, this is sum, and I will write, I'll copy paste this, I will not write it again. And if sum 2, no, not if sum 2, say new sum, yeah, n sum, int a. So I want you to do something with this new sum, n sum, so that the value, the original value of a is changed. Please don't answer right now. Take some minutes to think about it. Then someone who has not spoken till now should answer. So, question. Question. Can we change the original variable, the value of the original?
So can I?
Like 2-3 minutes, yeah. After
Okay, sir.
So this thing is what we will say that this is call by or better still put it here. Call by yeah, because this is what is calling the function. Yes, now you can say what to do.
Sir, in the function header, we can take int star a, so it will be a pointer, and from the calling statement, we can pass the address of a.
Okay.
And
So
here also we have to do star a is equal to
takes
star a plus star b.
pointers as arguments. Okay. And so let me do this step by step. So to avoid confusion. C B C C. Yes. And here, what should we write? How should we? I mean, yeah. Tell me. We'll declare C and D normally.
No, sir, we don't have to declare. We can pass the address of a and b.
No, no.
So
So
like we can
I
pass the address of the two
perfectly.
variables.
So I want two new integers, C and D. I can say C is
Yes, sir.
equal to 20, D is equal to 10. This I can say. Okay. And now tell me, what should I do?
And some ampersand c ampersand d.
One second. C D. And I put a C out here, no? I forget. Yes, C out. Okay, so what we'll do is C out C and del, and again we C equals T, and this is okay. What to do?
So star c is equal to star c plus star d. It will be in c out also.
Yeah, of course. So this is the, it is giving the address because I did not put the star. But if I put the star, yes. So, good. So the value of C has increased in the main function, and this is because calls by reference, it passes address. Okay. So yeah, two types here. One is called by value, the other is called by reference, and you can see to manipulate the value of the original variable, we have to pass. The function has to deal with pointers to that variable, yeah. And in that way it can change the value of the original variable. Okay, so this is another use of pointers. Okay. Now that we basically know that like by default arrays are passed by reference to functions, now you take again a few minutes and then someone else should tell me how, without using an explicit loop, I can find the maximum of this array. Okay, now it should be kind of easier. So question is, find the array. So now I'm saying explicit loop because if you do something clever without using like for or do while or while, It's still, I mean, it may be a kind of regression or anything. It has the same effect as, say, a while loop. Then I'll call it an implicit loop, nevertheless. Yeah, not an explicit loop. Yeah. Find the maximum element of an array without using an explicit loop. Yeah, so this one I want everyone to do at least on pen and paper. And after you finish, I mean, whoever finishes first should tell me. So for this you will not probably need call by reference. Call by reference is useful for I mean manipulating the array, but here you're not manipulating the array itself. So maybe when you do other things like sorting an array, you will need call by reference. But yeah, give me the maximum. Yes, anyone? Please try to write this and tell me what it should be.
So we will input the array using a loop, right?
Well, the thing that, like I said, try not to use, the loops. Yeah. So for next, I mean, for loops or while loops, do while, don't use this. Can we? Consider this only. This is our array. So you need not think about inputting the array. Now what can you do? So
Sir, recursion.
yeah. So tell me how to do it.
Sir, we need to give the entire array and the index we want to access and the max element till that index.
Yeah, that is too difficult for me. So tell me line by line, and so right, this um, this function, should it return any value, or can we do without returning any value? I mean, I'm happy if you print the maximum value. So
Yes, sir, you can return the maximum.
okay, so it is int. What do you want to name? So f max. Yeah, and this takes what?
The input array.
Okay, so it takes integer array. Okay, then
The array, the index we want to access.
I, right? Count.
Yes, sir.
And I think that should be enough.
No, sir.
Then
The size of the array.
sorry,
Size of the array.
I cannot hear you.
Size of the array.
Okay, size of the, yeah. So assume that it is 10. You know it is 10. The function should, I mean, you can use 10. Okay.
Then the max value.
Okay. Nice. Fine. So what do we do?
If counter is greater than 10, greater than or equal to 10.
If counter is
Greater than or equal to 10.
greater than
Equal to 10.
Okay.
Return max.
Return
Max.
max. Okay. Then
If else
else
if array at counter is greater than max. Max is equal to
yes, max is equal to. Okay. Then
return f max int array and counter plus 1 max.
we're inside this loop.
Yes, sir.
Okay. Return.
Actually, no, sir. Outside.
Sorry.
Outside.
Outside. Um, Here.
Yes.
Return f max. This, right?
Counter plus 1.
Counter plus 1. Okay. So let's try this then. what will be the value of f max? 19, no? Okay. So C out. We will have to C out. What was the order of? Okay. Array counter max. And I'll just put great work. So yeah, we should still, since I do not understand this yet, you should try to write down an explanation, which is also good practice. Okay. So this means that whole array has been traversed. So whole array has been traversed. So return max element, and this is just basically replace value of max with value of greater element, and this is function is recalled with index incremented by 1. Okay, so this is a loop, but it is like it's a recursion that works like a loop. It's implicit. Yeah, very good. So this is how we find the max value. And since since arrays are naturally passed by reference to functions, we can modify the above function to manipulate the values inside the array and perform operations like sorting it. Okay. And so you see here you have done counter plus 1 because you are moving to a greater index. So like if this was a linked list instead of an array, then a similar procedure could be used to traverse, manipulate, or what do you call it? Traverse or traverse or manipulate it without dealing with any index, right? Does anyone disagree with me? So yeah, this is I mean, this might not be very obvious, but you should try it at home. The same thing that so instead of saying counter plus 1, if you recall this thing, we were here. Oops, no, not this one. We were here. Oh no, I have lost it, I think. Okay. apparently I should write down the linked list once again. Yeah, which I'll do later on. So we'll not talk about the linked list today. Okay. So, but nevertheless, we can write this much at least. So instead of writing counter plus one, we could always write some, something like node next, to go to the next cell. Yeah, so try to do this at home, traversing linked list, full linked list using a function and no indices involved, no mathematical symbols involved. Okay. So this is one implementation of a function. Okay, that's fine. Save as, say, let's try to, I mean, yeah, we did, I hardly went into structures and classes, so we'll try to have an introduction to, say, we'll call this struct pro. And just let me check if this is, one can trust this. Yes, it is here. Okay. Fine. Okay. So we saw functions and how to call them by values and reference, or how to use them instead of loops. Basically, how to use recursions. Let's move on to the next topic. All right, so structures in sequences. So we have these simple data types like int, float, char, etc. there. And so we can say that, so these are simple data types and support simple, although very useful operations. And say arrays are derived data type, support more sophisticated operations as well as record keeping. However, one drawback or maybe an advantage, who am I to judge? So one feature of an array is that it stores multiple, say it's a value or variable. You can call them variable because they can be manipulated. Multiple entries, say entries is better, entries of a single data type. Okay? Single data type. But in the real world, we often need to store units of different data types. So, or better to state this, store single units comprised of different data types. For example, let's say employee name, employee age, employee post, employee salary. Or we can say that student name, roll number, joining year, right? What is it called? Yeah, joining year. So, joining year. CGPA. So, first is a string or a list of characters, the other is a number, integer, then also again some string, then it's a floating point. And similarly here, a string, this your roll number is, it has alphabet, no? A string, integer, floating point. So, and we have a lot of things like this. So, well, so hence we can, so structures facilitate the above. Okay. And so what can we do here? I want to write a structure. In C++, you have this advantage. Things are named according to what they are. So, struct. Yeah. So, this Sublime has recognized this keyword. Struct what? Student. Struct student. Okay. So, how to do this? Right now, okay, we have not done strings. We have not done strings. So I'll, yeah, strings maybe we'll cover tomorrow. So let's say roll number, joining here, CGPA. So I'll delete this roll number. Let it be an integer. Integer. Joining here should also be an integer. And this is float. The struct student int roll number. Roll number is sorry, cannot say this is equal to this or that. Int joining here and float CGPA. This is our structure. So this we have defined a structure. Structure is defined. Okay. And now, so I'm not saying that there's some student called Amit or any roll number. So some student called what is this here 21. So 2139. Some student with roll number 2139. Some student who has joined in 2021 and whose CGPA is maybe in the first semester he has got something like 9.5. I'm not saying that. I'm just saying what I want to say is that records for students are have this kind of unit where the student's roll number, which is an integer, the student's joining year, which is again an integer, and the student's CGPA, which is floating point number, are stored together. This is what I'm saying. So this is a general definition. This is not storing any particular student's records. Okay. Like just let's check if this is all right or not. And this is G++. Okay. And now I will try to define, I'll try to create a record for a particular student. And how may I do this? What is, so I need to create a unit, right? I need to give a variable name. So the usual way for declaring variables is a data type, then the name of the variable. So so someone else should tell me intuitively, if you don't know already, how I should create one record for a student. Someone who has not answered till now. I want to create a record for a single student. How do I start doing this?
The student A. So
Student A.
yes.
Okay. Then what do I do? I've declared a variable, and now I want to put values inside it.
So we can use dot operations.
Dot operator. So I will say that A dot, what was the thing? Roll number. 21, 31, 10. Or let it be like 2021, 31. So dot operator means, so this is called an object, right? A single instance of a structure. Okay, so it means that the roll number attribute of A, and similarly the roll number, the joining year will be 2021, and A dot CGPA is equal to, say, 9.45. Is this acceptable? Oh, it's acceptable. Fine. So can we, like, what happens if, so now I want to, like, what is the proof that all this has been really stored? So can we do like this? Cout A. No. So maybe we individually we can do this. Yes, this we can. Okay. So maybe some. Student B. Almost there. Oops, my bad. So notice I had forgotten this to input b.cgpa, and so its default value was 0. Yeah. Now it will give us the desired answer. Okay. So this is how you define a structure, access its members. You can change the values also. Yep. Okay. Well, so what I'm thinking is, can we, okay, so like structure variables can be individually accessed and changed by the above method. I want to do something else. Let me try this. So I will define another student. So let's see if this works or not. I'm not sure if this will work. Okay, so student C. So remember how we while defining an array, we initialized it. So with second brackets. So AR third bracket, like within third bracket we write 10 is equal to, then we in second bracket we write some numbers. So maybe this should work. This is also derived data type, more versatile than an array. So 72, and we can say that, yeah, same year, and 8.62. Let's see if this works or not. C dot CPN. Okay, it works. So structure object. Not sure if this is, yeah, I think this will be called object only. In the sort of class, it's called an object. Can be initialized at once. Okay. So this can be done. Yeah. And for cout, cout will not be able to do it like that because the cout is a different operation. Okay. So what else can we have? Yeah. So yeah. So these are like, it's a like the object is all-encompassing variable. Like it has three values, three like sub variables inside it. So can we, can we exchange these values? So student D is equal to student C. Is like student D. I do this. Can we do D is equal to C? And then so let me just write the verification part of this. Dot CGPA. Yeah. Let's see if this works. It's worked. Yeah. All structure values can be say exchanged. Yeah, exchanged. Not exchanged, but when we passed to another. So all object values, right? Object, because this here is a single instance. Object values can be passed to another object in a single step. Okay. Yeah. So this is pretty much it. Now, in array, we have this. I think I should. Anyway, so we'll deal with this later. But we have the concept of double dimension, right? Which is basically a matrix. So and multiple dimensions. So for double dimension, it's easy to visualize. So say some array with like 3 rows, 3 columns is basically a 3 cross 3 matrix. And basically, when we do matrix operations, we use this only. What I'm thinking is that can we have some nested structure? Like structures within structure. So let's see some other examples for this, and I will. Okay, so these examples are quite good, mostly from your book. So, struct room, okay, and here we'll say so we'll use imperial units, yeah, imperial units, and in the imperial units, the conversion is pretty much skewed, like 12 inches make a foot instead of things like 10 centimeters making a decimeter, 10 decimeters making a meter, etc., etc. So for distances, we need some so room whose dimensions are in imperial units, and this makes sense because when you when you say rent a flat or sell a flat or buy a flat, it's usually in square foot or square feet. I don't know what's grammatically correct. Yeah, basically we don't use square meters for this. Even say the height of, so yeah, we'll need to define distances, right? So struct distance, which is basically English distance, and we have int feet and float inches, and then we'll have struct room, which is okay, a rectangular area, and here we can write distance, length, distance, width. Now you can you can basically define your all the rooms, like say room dining, and you can say dining dot length dot feet is equal to 13, and dining dot length dot inches is equal to 6.5, and dining dot width dot feet, this should be an integer, and dining dot dining room is too big. All right. So float L is equal to dining length dot feet plus so area. I'm trying to calculate the area for this. I'm doing this dining length dot inches by 12, and float W. So for calculating area, this convention is useful. And now we can calculate the area. So this should be how much? 130. So 6.5 inches into 10, that is something like what, 135 or yeah. Personally, I prefer to convert the whole thing into inches and then do it, but yeah, yeah, 135 points. So this is like nested structure. So you can see that how you can access the nested structures. So dining. So it's like first you name the object, which is blue. So we are accessing like feet inside of length inside of dining, and so the objects are sorry, yeah. Objects are basically like written in the top-down manner. Here you access say inches inside width inside time. Yes. So can we? So let me open the other program. One-step initialization was, I mean, so just normally non-nested structures were initialized in this way, but we now know, we now have nested structures, so we can perhaps, instead of writing all this, yeah, I'll just comment it out. and we'll see if what we do now has the same effect or not. Just let me see here. This was 135.417. Okay. Yes. Now, instead of doing so many things, what if I sorry. So dining room has, okay, so room has like two structures inside it, two substructures inside it, which have two substructures inside it. Okay, so it is like this curly bracket is for the first one, this is for the second one. And what was the first variable? Well, okay, 13. 13 comma 6.5. 10 comma 0.0. Okay, let's see if this works, because in like multi-dimensional arrays also you can insert values like this. So this seems to be a generalization of arrays, no? Yeah, it is still the same. So this is just a short way of initializing instead of writing all this. Okay, good. So there can be several, I mean, if you're, say, making a structure for a whole apartment building, then it can have more depth. And it is pretty much this. Okay. So now, another example. So yeah, I forgot to mention this before, but there are some other kinds of yeah, yeah. Perhaps this is the right time to do this. There's a kind of like, so structures are what? Structures are derived data types or user defined data types, which clump several types of like primary or simple data types. So another way of, so now that we know how to write structures, we can kind of have kind of simple data types which we ourselves define, which is basically called an enumerated data type. So this is the keyword, enumerate. Days of week, which is basically Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Here we have defined our days of the week, and we can, of course, in the same manner, we can declare object. So days of week, day 1, day 1, day 2. And now we can treat these like, say, as if like just like how, so think of this as integer and this is 1 to 10 into integers within 1 to 10. We can write this: day 1 is equal to Monday, day 2 is equal to Tuesday, and so on. But the surprising thing, okay, just let's see, just check if this works or not. See out day 1 and then oh, what has happened? It is giving 1. That means that if I write day 2, then what will happen? Oh, well, now let's change this to Thursday. So it is giving the index, and perhaps we can do some like arithmetic on this. The number of days, that is the difference. Okay, so this is also possible. Yeah. So this is another implement. I mean, yeah, this is not. Yeah, I don't use this in my course, but this is something similar to structures on elementary skill. Now what we can do is, so this is basically, this enables logical and mathematical operations. Okay. Yeah. Right. So there's not much else to do. Let's take a short 5 minutes break, then we can start. So we are at a logical point to start classes. After 5 minutes, we'll start with classes. Let's take a short break. we can come back now. So classes. Yes. I will change the name of this to oh. Now we have already seen what structures are, and now classes also, I mean, in a way, so to begin with, all of this that is happening in structures, classes to do something similar, but we'll learn the differences. First, let's see if this structure is, I mean, can be considered in many ways a proper subset of classes or not. What if I do this? Yeah, class has also been recognized as a keyword. Okay. Will this run? Not sure. Okay, so something is wrong. What is wrong? So what is the error that we are getting? See, I mean, in some ways classes and structures look pretty much the same, but here we are getting an error. So classes also do pretty much same job, but they are very versatile compared to structures. Classes also they create like derived data types comprised of multiple data types. Yeah. But this error, it is saying roll number is private within this context, as if we cannot access roll number from outside. Same thing is happening everywhere. Everywhere it is saying that it is private. So like, can we do something to overcome this? As soon as I change a structure into a class, so one difference between structure and class, which is, I mean, implied by this, is that in structure by default the variables are quite open or public, like they support public access. You can access them from outside and do anything you want. See, I've accessed them from outside when it was a structure. Class, as soon as I changed the type from structure, type of student from structure to class, there is a barrier that is coming. Okay, so I for the time being, I just want to get rid of this. I want things to be easy, things to be compiled. What should I do? Someone else please answer, not someone who has already answered. See the error and tell me what should I do. In structure by default everything is very open. In classes everything is quite closed, that we understand. So this is the first difference. So like, what do you think we can, I mean, it's okay, it's not obvious, but any hint?
So you can assign all those variables as public.
Yeah, so I can define these as public. Yes, let's see if this works or not. It's worked. Thank you. So now that I've said that these variables are public, I can access them outside the class. But if I wanted to hide something, or like not hide, maybe some other people will work on different parts of the code which will contain this class. If for convenience I want to keep something to myself or to another select group of programmers, then I would like to keep them private. Yeah, private. So integer. So what should be private here? Well, no reason to keep this private, but it can be private if I want to. Okay. Yes. So this one, float SGPA cannot be accessed from outside. No, it cannot be accessed from outside. Okay. Fine. One more thing that we can do is we can include functions here, and what can a function be for this? What can I give as a function for this one? Say void print data. I can say void print data, and it should not require anything, but it will see out roll number equal to. So since I'm writing the definition inside the class itself, I don't need to. I mean, this is a general thing. Yeah, there's no like dot operator is not required because this is not particular to any object. This is something that holds for the full class. Means like this is a member function for a class. I can include functions inside a class. And yes, in the end, I will say handle and so it should work in the same way, no? So if I access like if I use the dot operator, a dot print data, sorry. Okay, so this is working. I'll make this a little bit grammatically correct. Right. So this is how a member function works. But the thing is that if I cannot access this private variable at all, I mean, what is the point of having such things? So there is, so this separation between private and public is, you know, it has a meaning. I cannot access, cannot be accessed from outside. Access normally from outside. I cannot just simply call the object and access this. But if I say So what I want to demonstrate is that what I want to demonstrate is that the member functions that are public but are defined as a part of the class, they can very well access the private members. Okay. So let's see. Yes, it is giving some answer. There you have it. Okay. Wait, why is the 0 not there? Let me make this 9.75, and let me see what it gives. Yeah, fine. So right, private members can be accessed by so is it only public member functions, or can public variables also like access these private members? So what if I do this is HTTP/2. Just let's check. Okay. So this is HTTP/2. Okay. Now it should give some CGPA is 4 point something. No. No. Initially, I have not. Maybe this will give an error because the ordering is not proper. No, it's been overwritten somehow. Okay. How to just 1 second. Inside this, how do I? If I set data like this, then so yeah, just forget it. This just it's conflicting somehow in the order, and yeah. So let's now just be contented with saying that private members can be accessed by public functions of the same class. Okay. Fine. So we yeah, pretty much this is what class looks like, and you will have this. You can have more functions that manipulate this thing. But so now the question is, yeah, this feature, this particular feature, it's very important in object-oriented programming. So this hiding some data. What is it called? Anyone else, please? The like restricting data access in object-oriented programming. What is it called? It has a particular name.
So data encapsulation.
Data
Abstraction.
abstraction. And encapsulation is what?
Encapsulation is. Sir, I forgot that.
Anyone else? Encapsulation meaning?
So we hide the implementation of the class.
Sorry?
We hide the implementation of the class.
Yes, pretty much. Okay. Yeah, this is our first feature of the of object-oriented programming. Okay, one more thing we should know here, that by default the variables the data that we put, that was private, yeah, which is why we got so many errors. But if we don't mention public and private uh, explicitly, all data is private. So let me write down. By default, data is private, but functions are public. Okay. Because data we can, so mostly we want that the data should, I mean, original record should not cannot be changed arbitrarily, but functions should be accessible from outside. This is one feature. So suppose, right, yeah, we have called member functions like this, and what else? Okay, so we jump to constructors. So we can, of course, if some let me, yeah. So if some variable is public, we can pass values to it later, like initialize it later from the main function. Or if it is private, we can do so using a member function. Okay. But so like we did for structures, this initialization right when something is created, an object is created, uh, that also is very convenient, but that is not done in classes, and that's not doable in classes in a direct manner. So we use a special member function called a constructor. So so as soon as you create an object, this like the constructor is executed automatically. Okay, let's see another example. So some integer count. This is by default, but let's write down still. Private count and public. Okay, I just write the main function first. Um, okay, so let's see what is happening here. So this is our class counter, which basically uh, has only like one variable, which is private, and so it needs to be initialized when this is defined. So this is the constructor, and so this is increments count by 1, returns count. And here what we do is defined and initialized constructor, and then both should be 0. C0 and C1 and C2 both are 0. And here this is C1 is incremented by 1 and C2 is incremented by 2. Yeah, so if I give this 1, then what would happen? So you can see how the initialization is working. So due to the definition of the class, due to the presence of a constructor, it is initiated to 0. What I want to see is, what if I disable this constructor? Oh, so that means, see, actually so some mistake that I made a bit while ago. That was also giving the same result. So that means the variables have a default constructor. Yes, because otherwise this should have given some junk value. See, everything is initialized to 0. Okay. Just to just to make sure, is it only private variables that have default constructors, or you can have public variables also with the same property? Yeah. So both private and public variables have constructors, default constructors. Yeah, unless we want to change the value, that will show. Okay. So that's the automatic initialization. Point to note: constructor has same name as the class. So let me write down here, because here you can relate with the example. Constructor must have, so default constructor initializing variable to 0 is there, unless explicitly defined by our evidence that we saw. Or I'm not sure whether the default thing is called a constructor, but yeah. So we have something by default is present which will give initialize to 0. So initialize private and public variables to 0. Initialize any, because or this is better to state. Okay, and name of the constructor must be the name of the class as well. So you see, this is like so since there's no return type, yeah. Constructor is a function that has typically a unique look, because there's no return data type present. Okay, and the compiler can instantly identify it, because it looks different from other components, other functions. So the constructor basically, yeah, initializes the member variables. But yeah, so you can see this like normally a function should have looked something very different, no? Because inside, we could write counter, then this open and close first bracket, and then instead of doing this, maybe we could have written this like something like this, just to check whether it allows us to write a constructor like a normal function or not. This would be the case if it was written like other functions, right? So is this just a fancy way to write a constructor, or like it is the only allowed way? Let's see if the normal way is allowed or not. Oh, the normal way seems to be allowed. No, okay, we have the same place, and let's say if this is works as well. Okay. So the thing is that since this can be done, so we clearly understand that since the compiler is allowing both, maybe it was not allowed in some previous option, who knows, but as of now the constructors can be written in the conventional way or in this special way. We preferred the special way to distinguish it from other functions. Yeah. And it's kind of handy also. We'll see why. So count maybe int m1, int m2. Suppose some variables are like this. Then we can straight away here we can write m2 4, m3 5. Just let's check. So out c1 dot m1, right? M1 oh, I've this will not work because these are private, and so what to do? Now this should work, and we can just write out. Yeah. Right. Just one. Yeah. Right. So this way of writing a counter is handy as well, because you can just in series you can initialize all the variables. Okay. Okay. So this is how constructors are automatically. This is how variables are either they're automatically initialized or you can initialize them in a class. So like these values are given automatically when you define an object. The initial values are obtained like this. Okay. So when an object, you want to get rid of it, you must destroy the whatever is inside that object. And so just like constructor initializes the object, to destroy it you use a destructor, or how to destructor, not destructor, destructor. So say it is quite similar to the constructor, except that so the name should be, what is the name of our constructor here? It is counter. So tilde this, and that is our destructor. So they don't return anything, and of course, since it is destroying an object, what input will, what argument will it take? So no argument. Okay. And yeah, this is used as, so like it frees up memory space, deallocates the memory that was previously allocated for the object, and so just forget it for now. We'll come back for these later. Okay. So now that we have, now that we know the preliminary like description of a class, what can we do with classes? So again, as I like to look at it, classes are, of course, they are a more versatile version of structures, but you can consider them as maybe some multi data type, so some list having multiple data types inside. So like it should also be showing the characteristics that arrays show, because instead of an array, when we have multiple data types, we are using classes. So what are these things that can be done with classes or objects? Okay. Again, we can return to our original, not original, but one of the, I'll just try to write it anyway. Our imperial units of distance again. So private feet, and the float inches. Public distance, and this is our constructor. As you can see, it has the same, so it's easy to identify because it has the same name as a class. Feet 0, inches 0.0, and yeah, this is it. Okay. So this was our constructor. Another way of writing a constructor is So this is the conventional way. We can write it in this way also. And just let's skip this for now. This will get the distance from the user. And this one will print the distance. And so this I have defined inside the class itself. I will just declare a function here for adding two distances. And so this particular distance, this particular function, it takes two distances in the imperial units. So like, see, each distance is itself stored in an object in the form of feet and inches. Right? So to add two distances, you will have to supply the function. So one distance in feet and inches, the other distance in feet and inches. So basically, two things come together, and so two objects, right? Distance one, distance two. So this should look like distance. Okay, it's declared like this. Now I will define the function outside of the class. So I'll have to first specify that it is indeed, something that we have already declared in the class definition. And I'll say void distance. This is inside the double colon operator. It's inside the class. Distance t2 comma t3 So I'll say this is inches is equal to the inches of T2, object T2, plus the inches of object D3. So let feet equal 0 initially, and then so first what I'll do, I'll see if there's a carry for the inches. Yeah, if D inches of D2 plus inches of D3 is greater than 12, that I should have to find out first. So if inches greater than equal to 12 plus 0, inches is equal to inches minus 1.0, and feet plus this. So each time it is greater than 12, like number of feet increases by 1. That makes sense. And finally, the addition for feet is, so already whatever I've got, I mean, like, so it can be maximum 1 foot extra, right? So 11 inches plus 11 inches is equal to 1 foot plus 10 inches. That kind of thing it will be. Okay, so that is basically, so our value of feet has been stored. It's either 0 or 1 from the inches, and this is equal to feet plus feet of D2 plus feet of D3. Okay. And now we will here we'll define distance, dist now dist 1, dist 3, and 1 second, I have last distances are okay. Distance dist 2 I'm defining and initializing 6.25, and so dist 1 dot get dist dist 3 dot add dist 1 plus and distance 2. Okay, fine. So this one is already declared. I mean, so distance 2 is initialized inside the main body. Distance 1 we will input, and distance 3 will be the sum of these two. So let's also see the output. See out 1 ml please. See out 1 is equal to I've done something wrong, and one. Let's find out. What error is this? Let's do some troubleshooting. Okay, yeah, this initialization is making the trouble. And what could be the reason? Okay, wait, let's look at these things here. Distance is feet and inches. This is public. That is okay. This is private, and uh, I cannot initialize like this. So the yeah, no matching function. Okay. Double.
Sir, you commented that you commented the constructor that takes integer and float as input, sir.
Oh, this one, no?
Yes.
Yes.
And there you should write the initializer list, sir.
Yes. Right. Yeah. So I'm invoking the constructor here. Oops. Yes. Thank you. Okay. And right. What mistake did I make? Just 1 second. This is okay. So okay, dist one, show dist. And the error is no, wait. So cout is right.
Sir, show dist is void, sir.
Show dist is void.
Yes, sir, the return type.
Yeah. So, but it is just okay. So yeah, it does not return anything. That
yes, sir. Yes.
But what I'm doing is okay. Yeah. So I'm trying to see out this, but I'll just have to write this like this. Let me see once. Just 1 second. Element void and unresolved. Because I'm calling show list, and why should I have this here? Let's see if this works. Right. I should put a separate handle here. Right. And yeah, now this. That is okay. Let me repeat this 2 times. Okay, so this one is 11, that is 6.25. I better give something like 1 and say 9.75. Okay, there is some problem here. This is all right. What have I done? Okay, so this guy is taking that. Okay. We are taking get dist from here, and all right, show dist. That is also fine. This is 2 is here. Okay, so we are having an error for distance 2, and let me see. Okay, distance 2 is what I'm trying to input through the constructor, and why is it not taking the value? Okay, so it's taking a junk value because yeah, so sorry, I should write here. It doesn't make any sense, ft and in, and then unless I write feet gets value ft and inches gets value in. Now it should work. Yeah. Otherwise it is taking junk values. So back to 1 and 9.75. Okay, now let me see this. The addition, it should be how much? 16 there, and so 13 foot 4 inches, right? Yes, okay. So this works, and yeah, where were we getting stuck? Where was I getting stuck? Okay, another way of writing a constructor so that it can be invoked by the main body, by the main function, and passed values. Yes, so this is the function. Okay, so double colon signifies that it belongs to the distance class and finally this function takes objects as arguments. Okay, so we have seen we have just started with classes, not much complicated implementation, and we are now just playing around with objects. Next, okay, next topics to start is more convenient ways to pass objects, or we should probably see. Okay, now that we know preliminarily what classes mean, maybe we should see a definition. I mean, we should complete the implementation with linked list, and also we need to see for your lab, we'll need to see some preliminary input output like file operations in C++. I think let's continue. So let's continue tomorrow. Yeah, so we are having a lot of classes in the beginning, so it's good in a way because then near the second half of the semester your load will be less. So we shall meet tomorrow then at 2. Okay, and we'll complete whatever is needed for your Wednesday lab. So tomorrow is there will be no practice lab tomorrow. Tomorrow there will be regular class from 2 to 5.